Hello everyone, welcome to my channel. For today, we're going to do the adjustment of a chain of triangles. So in the adjustment of measured quantities in triangulation, two basic objectives are the removal of inconsistencies and the prevention of error accumulation. The adjustment of triangulation data may be undertaken by the exact method, called the method of least squares, or by the approximate method. So today we're going to focus on the approximate method. So this method involves two steps. First is the station adjustment to be followed by the figure adjustment. So in station adjustment, its objective is to make the sum of the angles about each station equal to 360. Why is that? So here's an example. We have a figure A here where there is a station A, and station A is composed of three angles because in A here, all the surrounding angles should be equal to 360 degrees, forming a circle. So about station A, the sum of these angles shall be equal to 360, and if it doesn't, then the angles should be adjusted. After the summation of your angle is determined, you will then get the error. So to get that, you just have to subtract your summation from the 360 degrees. And then, the resulting difference is then divided by the number of angles about the station. So in this case, your correction should be equal to error over n, where n is the number of angles in that station. After that, this correction should be added to your angle to get your adjusted value of each angle. To check, you can then add your adjusted values and the sum of that be equal to 360. So the next step of approximate method is figure adjustment. This adjustment, which is performed only after station adjustment, uses the values obtained in the first adjustment. It requires that the sum of the angles for each triangle should equal to 180 degrees. So if we consider this example in our figure, considering triangle ABC, we have interior angles of the triangle C, E, and F. So their summation should be equal to 180 degrees. So if the summation of these three interior angles of the triangle doesn't equal to 180 degrees, then the angles should be adjusted. You just have to subtract these summations from the 180 to get the error, and then substitute this error to the correction divided by n. And this error divided by n, where n is the number of angles in the triangle, will be added to the first adjusted value or first adjusted angle to get the new adjusted value of the interior angles. So we have an example here. We have a triangulation A, B, C, D, E, F. So in the approximate method, we're going to first adjust each station, then adjust each triangle. So for first adjustment, the station adjustment. Okay, so let's say we'll start at A and then B, C, and so on. So at station A, we have angles A, B, and C. So the sum of the angles at station A, we have the values of these angles here. For A, we have 240 degrees, 21 minutes, and 0 seconds, plus our B, 60 degrees, 29 minutes, and 10 seconds, plus our C of 59 degrees, 10 minutes, and 5 seconds. So the summation of these angles is equal to 360 degrees, 0 minute, and 15 seconds. So our summation of these angles exceeds 360 degrees. So to know the error, we just simply subtract our summation from 360 degrees. So that, okay, here you go. So our error in that station is equal to negative 15 degrees. For the correction to be applied to each angles in that station, simply divide that error by the number of angles. So negative 15 seconds divided by 3. Since we have 3 angles at station A, our correction would be negative 5 seconds. So to get the value of each angle, let's put a prime for each adjusted value. So in this case, A prime for A. So that would be A plus the correction. So our angle A is 240 degrees and 21 minutes plus the correction of negative 5 seconds. So our adjusted value of A is 240 degrees, 20 minutes, and 55 seconds. For B, since our B is equal to 60 degrees, 29 minutes, and 10 seconds, that is 9. Just adding the correction of negative 5 seconds. Our adjusted value for B at station A is equal to 6 degrees, 29 minutes, and 5 seconds. For our third angle at this station, which is the angle C, 59 degrees, 10 minutes, 5 seconds, plus the correction of 5 seconds, negative 5 seconds. Our new value for C is 59 degrees, 10 minutes. So the summation of these angles is equal to 360 degrees. So since we've already corrected all the angles at station A, we can now proceed to station B. So you just have to follow the same solution, okay, until you reach station F. You can also tabulate your solution in this format. For our station A, you can put the correction. Since we already solved the corrections for station A, we can just input it here. The correction is negative 5 seconds. So simply input negative 5 seconds in your table. Since our total correction is equal to 15, or our error, so you're going to apply that from your summation of your original angles. So adding the correction from your observed value, you can get your adjusted value, like what we did earlier. So in summary, this is your new adjusted values for these angles at each station after the station adjustment. But we are not yet done in our problem. We still have to solve or to adjust the chain of triangles by the figure adjustment. Since we are done with the station adjustment, let's proceed to the figure adjustment. Consider triangle ABC. This triangle. So remember that in figure adjustment, the sum of the 3 angles in each triangle should be equal to 180 degrees. If this condition is not satisfied, their sum is subtracted from 180 degrees, and to each of the three angles, 1/3 of the difference is added algebraically. Okay, so considering triangle ABC, we have the interior angles E, C, and F. These angles. So we're going to use the angles that we've already adjusted from the station adjustment. So the sum of that, C prime plus E prime plus F prime. Our C prime is 59 degrees, 10 minutes, 0 second, plus 58 degrees for our E prime, 25 minutes and 13 seconds, plus our F prime of 62 degrees, 25 minutes and 13 seconds. So the sum of these angles is equal to 180 degrees, 0 minute and 25 seconds. So calculating for the error of our triangle, we get, just subtract the sum from 180 degrees. Okay, we'll get 25 seconds. So dividing this 25 seconds, negative 25 seconds, by our n, we'll simply get our correction, where n is the number of the interior angles in your triangle. So negative 25 seconds divided by 3 is equal to negative 8.33. Say negative 8 seconds. So in adjusting the angles or in applying this correction, the correction is applied arbitrarily. Since we have an extra 0.33 second. Okay, so you can just simply consider the larger number or the largest number among the largest angle among the three angles in your triangle. You're going to apply the larger correction to that largest angle. So in this case, since we have um, f as the larger or the largest, sorry, since we have f as the largest angle in our triangle, we're going to apply the correction of 9 seconds, and for the rest is 8 seconds. So the correction for C double prime. So since we've already used C prime in our previous adjustment, we're going to name it double prime. So C double prime is equal to C prime plus our correction of negative 8 seconds. So since our C prime is 59 degrees, 10 minutes, plus our correction of negative 8 seconds. Negative 8 seconds. Our C double prime, or the new corrected value of C prime, is 59 degrees, 9 minutes, and 52 seconds. For our E double prime equals E prime plus the correction. So since our E prime is 58 degrees, 25 minutes, and 13 seconds, then added by negative 8 seconds, our new E prime or our E double prime is equal to 58 degrees, 25 minutes, and 5 seconds. So the correction is applied arbitrarily. So for our F double prime, our correction will be 9 seconds or negative 9 seconds. So our F prime is equal to 62 degrees, 25 minutes, and 12 seconds plus negative 9 seconds. So our new f prime is equal to 62 degrees 25 minutes and 3 seconds. So that is our double f prime. F double prime, sorry. So the summation of this angle is equal to 180 degrees. Now, you can proceed to triangle ACD, CDE, and DEF by applying simply these solutions that we have discussed. Okay? So by considering these triangles and adjusting the angles inside them, we will get these answers. So if you have observed here, for triangle ACD, since the largest among these angles is angle B or B prime, we have added 12 and subtracted 11 from them. So the same with CDE, which has a total error of 31, negative 31 seconds, divided by 3, that is 10 seconds, point 33. Negative 10 seconds, point 33. So we have to add the correction or apply the correction arbitrarily. And by doing that, let's just use the 11 or apply the 11 to the largest angle in the triangle. So in other words, the largest angle in the triangle shall receive the larger error or the larger correction. Okay, so that would be all. Thank you so much for watching, and please subscribe to my channel for more videos and tutorials. Have a good day.